Hello. So now we'll study the black body. What is black body? There are two ways to explain it. One thing, it is black. Some people say it is black. Some people say it is invisible. They are partly right and partly wrong also. They are partly right because whatever black body we see in general, we define in general, they falls into this category. They are black and we are not able to see them. But when we go for basic definition of black body, basic definition of black body is defined. Why we define the black body? We need black body so that the radiation as a process we can define. We should have something to compare with. So, in reality, if I'm having a system or black body as a system, if I'm having a black body, which is my system this time, and let's say the temperature of the black body is T and the outside temperature is T0. So this is my black body. This is the black body or any black body. There is no black body 1, black body 2, black body 3. Black body means black body. So if some energy will be incident upon it, so in case of normal case scenarios, what happens when some energy incident upon some normal bodies, part of it gets absorbed and part of it gets reflected. And the normal systems, they tends to emit also. Here we are having a black body. So in case of black body, if the energy is incident upon the body, the reflection is always zero. It don't reflect anything. Or we can say whatever is incident upon the black body, everything gets consumed by the body. So it's like a biggest beggar possible. So whatever energy you are throwing at big black body, it is going to absorb that thing. And that's why people say it is invisible, because you see, out of the black body there is no reflection. Reflection is zero. So there is no reflection coming out of the black body. But the thing is, you don't see a body by just its reflection. Because this black body is having some temperature T also. And since black body is having some temperature T, it will emit also. The emission is non-zero. So when you see something, you receive the rays which are coming through the reflection and emission. So you'll not be getting any idea regarding what was incident upon it, because everything incident upon the black body gets absorbed. But you see the black body, you can see the black body from its emission. So emission, whatever black body is emitting, that you can see. But the thing is, generally, whenever some black body, in normal, when you have the black bodies, their emission don't fall into the visible range. So due to that, you are not able to see the black body. But in reality, you can see. If you develop some mechanisms to see the bodies using the ultraviolet as well as infrared, you will be able to see the black bodies, because they will be emitting some of the energy which will be in that zone. Okay. So my black body, as a definition of black body, is that the black body absorbs everything. Everything it absorbs. So it's like a biggest beggar possible. So let's just compare this black body with a real system. So if I'm having a real system, this is my real body. So this is some real body. And this time I'm assuming this real body as my system, and I'm assuming it is having the same temperature. Outside temperature is also same. So if you want to compare between two bodies, they should have all the things similar. So their cross-section area, their temperature, the surrounding temperature, everything is same. Everything is same. And I'm going to, the incident energy onto the real body will also be same. We have to assume that. That's when we will be able to compare between the real body and the black body. So let's say I is the energy which is incident upon the black body as well as the real body. In case of black body, everything gets consumed. So basically, in case of black body, I is equals to A. And value of R is 0. But when you talk about the real body, in case of real body, it will absorb some, it will reflect some. So here, I will be equals to R1 plus A1. So it is absorbing some, it is reflecting some. So since incident was same in case of real body as well as the black body, incident energy was same in case of black body as well as the real body. Here the A will be A1, the absorption will be less than the I, because you see, it is reflecting also. So I value is equals to A. So if I say for the real body, real body, absorption by the real body will always be less than the absorption by the black body. So black body will be absorbing more and real body will be absorbing less, corresponding to the same energy incident upon both the bodies. If they are having the same cross-section area and the temperature outside and inside is same. So that's the result we are getting. So the thing is, we define a constant, and that constant we define as absorbability. We define a constant which we define as absorptivity, small a. We represent it by small a. So small a value is equals to A1 upon A. So it is equals to A1 is absorption by the real body corresponding to the incident I. And A is absorption by the black body corresponding to the same incident. So the proportion between the absorption by the real body with respect to the absorption by the black body corresponding to the same incident energy is defined as absorptivity, and this value is a constant. You see, if you increase the I here and increase the I here also, so their ratio will always maintain themselves. So if you increase the I here, let's say you make it double, obviously A will become double. And if you make this I double, here also A1 will become double. The ratio of absorption by the real body and the absorption by the black body corresponding to same I and same temperature cross-section area will always be a constant, and that constant we define as absorptivity. Small a we represent. Or we can say this thing is nothing but A1 upon I, because you see A is nothing but I. It is equals to the incident energy. So corresponding to the incident energy, amount of energy absorbed by the real body, this value always remain constant. So A1 upon I value for a real body is always a constant, and that value we define as A. The absorptivity for a black body will be 1, because in case of black body, if you see, absorption and incident both are same things. So A we define as absorption by real body divided by energy incident upon it. So this absorptivity for the real body is a constant. And this thing you can apply for the black body also. Only thing you have to do, you will be replacing this real body by the black body. And in that case, A will become 1. So absorption for black body is 1, because in case of black body absorbs everything. Okay. So this was regarding the absorption. We have compared the black body with the real body for absorption. Let's talk about the emission also. So see, here this black body is emitting E, and I'm calling this EB, let's say, for a time being. So real body will be emitting something, ER also. So this EB is the emission by the black body when the black body was having the temperature T, outside was T0 and A cross section area. And we were having the same real body which was emitting ER. Okay, this R stands for real. And the black body and the real body were having the same temperature, same cross section area. We can compare between these emissions also. The thing is, this emission by the real body with respect to black body is defined as one more constant, and that we define as emissivity. We define it by small e. This emissivity is defined as emission by real body. Emission by real body when the temperature of the real body is T and the cross-section area is A. We can only compare when the temperature and the cross-section area are same. Divided by emission by black body for same temperature and same cross-section area. This value is defined as emissivity. And obviously emissivity with respect to the black body, emissivity for the black body with respect to the black body will always be 1. So emissivity is a constant by which we measure the emission power of real body with respect to black body. And through experiment, we always come across that E will always be less than or equals to 1. So basically we can say if we are having two bodies, one is black body and another is real body, and both are having same cross-section area and same temperature. In that case, black body will be emitting the maximum energy. Any real body you talk about, that emission of any real body will be less than the black body. So now you can see the black body absorbs max as well as black body emits max also when compared to the real bodies. So absorption, for comparison between the absorption of real body and black body, we define a constant absorptivity, and for comparison between the emission of black body and real body, we define a constant as emissivity, that is small e. Okay, so this is the black body. The black body, the first thing why we define the black body, because we need something with respect to which we can define this radiation as a phenomena. When we talk about radiation, it's a combination of emission as well as absorption. So now with respect to black body, we can define any body by giving the value small e and small a for the real body. If I know the small a value for real body, I can calculate how much it is going to absorb corresponding to I, because I'm having this formula. Small a is equals to absorption divided by the incident. This is the incident energy. So if I have the incident, I'll be having the absorption if I'm having small a, and if I'm having the absorption as well as incident, I'll be having the reflection also. So if I'm having the absorptivity as a constant for the real body, absorptivity constant for the real body, I can calculate how much this real body is going to absorb and how much this real body is going to reflect corresponding to the incident energy. And if I'm having the emissivity for the real body, in that case, if I know how much emission this black body is going to do, which we will do later on, if I know how much emission this black body is going to do, I can calculate the emission done by the real body also. That will be equals to the E times of emission by black body, which is having the same temperature and cross-section area. Okay, so with these two constants, I can calculate absorption and the emission and reflection for any real body possible, if I know these things for my black body. So all I need to do now is to calculate emission for black body. Okay, thank you.